Alright guys, we're going to be talking about EKG today. So this stands for electrocardiogram. So this is going to basically record the electrical activity of the heart. We're going to start off with the basics and kind of work our way up. Let's talk about the waves we're dealing with first. What I'm going to talk about is this thing called a baseline. So what's happening with the baseline is nothing's going on. The heart is not beating. But what's happening in your chest, your heart's going bump, 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 bump. You see there's a period of time between heartbeats. So that is our baseline. The next thing we have is we got our P wave over here. And so our P wave is when the top part of the heart contracts. And that top part of the heart is called the atria. And the top part of the heart's contracting, then the top part of the heart goes through another beat. Now, this next section right here is called a QRS, right? And so I'm talking about all of this thing right here. This is a QRS. This whole thing right here, once again, is a QRS. This is the bottom part of the heart squeezing. The next thing we have is a T wave. This T wave is the bottom part of the heart is relaxing, starting to open back up here. Once the bottom part of the heart is fully relaxed, we're going into our baseline until the top part of the heart contracts. A couple of things you want to know here. This is going to be our interval. This is basically switching from the top part of the heart contracting to the bottom part of the heart contracting. This little space is called a ST segment. This is our ST segment. We're switching from the heart contracting to the heart's going to start relaxing here. Now that we got basics of what we're talking about, let's apply it to the situation right here. So here's what's called our electrocardiograph grid. You can see there's lots of boxes here. First thing you want to be aware of when you're looking at this is time. As I go from left to right on this thing, I'm measuring time. As I'm going from bottom to top, I'm measuring voltage. Now, we have to call something zero. It doesn't matter if you start here, 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 wherever you start, that's going to be zero in terms of voltage. Same idea in terms of our time. So we could start here, 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 here. You have to call something zero. So what we have, just for the sake of simplicity, I'm going to call this 0 seconds, 0 millivolts. Remember, it doesn't matter how far up or down I go, I'm still at 0 seconds. Now my millivolts is changing. It doesn't matter how far to the left or right I go, I'm still at 0 millivolts. So let's draw kind of a sample thing real fast. And so this is, once again, this is our 0, 0, right? 0 seconds, 0 millivolts. So how much time did this PR interval take? So remember, your PR interval starts at the beginning of the P wave and ends right before our QRS. So we're going to measure this very simple. We're going to talk about little boxes. So it's going to take me 1, 2, 3, 4 little boxes. A common mistake that students do is to say, oh, this is going to take me 1, 2, 3, 4, 5, 6, 7, 8. No, it's not taking 8 little boxes worth of time, right? This right here, right, what's the least amount of little boxes it's going to take me to go from here to here? That's 4. And so it's going to take me 4 little boxes worth of time. Alright, now if I were to say, hey, how much time did this take me? My QRS, right? Once again, from the start of my QRS to the end of my QRS, how many little boxes is this? 1, 2 little boxes. My ST segment, how long is this taking me? Alright, from the start, the end of my QRS to right before my T wave, that's going to be 1 little box. How wide is my T wave? From the start of my T wave, how long is my T wave taking from the start of my T wave to the end of my T wave? That's going to take 1, 2, 3 little boxes, right? So that's how you measure that time in terms of little boxes. Most of us aren't going to say, hey, I'll be there in 3 little boxes, right? Your family and friends would look at you kind of weird. Well, the same thing kind of happens here. So we got to convert little boxes into time. How much time is 1 little box? So 1 little box equals 0.04 seconds. So going back to that initial thing, how long did my P wave take me? 0.04, 0.08, right? Because it took me 2 little boxes. How long is my PR? from here to there, that's 4 little boxes. 4, 8, 12, 16, 0.16 seconds. My QRS, how long did that take me? Remember, count 2 little boxes, so 0.04, 0.08 seconds. My ST, 1 little box is 0.04 seconds. My T wave, 1, 2, 3 little boxes, 4, 8, 12, 0.12 seconds. Why? Because each little box is 0.04 seconds. Once again, that's as we're going this way, back and forth. I don't care how far up you go or how far down you go, it does not change. If I go from here to here, as I go from left to right, it's still taking me 5, 10, 15 little boxes. It's going to take me 0.6 seconds. This is still taking me 0.6 seconds. Next thing, let's talk about millivolts, or let's talk about the voltage here. If I wanted to know what the voltage, the maximum voltage of this P wave is, remember this is 0, right? All the way through, this dark blue line is going to be 0. Right here, I'm 2 little boxes above 0. How low did my QRS go? 1 little box below 0. How high did my QRS go? 1, 2, 3 little boxes above 0. How high did my T wave go? 1, 2, 3 little boxes above 0. How high did my P wave over here go? 1, 2 little boxes above 0. But once again, we typically don't like to talk about voltages in terms of little boxes. Oh, I need some AA batteries. How many little boxes of charge do you want? They're like, what the heck are you talking about? We talk about volts. Our voltage is so small with these little boxes that 1 little box is going to be equal to 0.1 millivolts. To put that into perspective, your AA batteries, your AAA batteries, they're 1.5 volts. You would take 15,000 of these little boxes stacked on top of each other to represent the amount of voltage that you have in a AAA battery or a AA battery, because this is ridiculously sensitive. So we're not dealing with large voltages, we're dealing with very, very small voltages. Now that we measure this in terms of little boxes, how much millivolts is this? Alright, so 0.1, 0.2. So this is 0.2 millivolts. What's the millivoltage of this? Well, I'm 1 little box below baseline, so that's negative 0.1 millivolts. What's my millivolts right here? I'm 3 little boxes above baseline, so that's 0.1, 0.2, 0.3 millivolts. I'm 1 little box below baseline, so that's going to be negative 0.1 millivolts. I'm 3 little boxes above baseline, that's going to be 0.3 millivolts. Once again, 0.1, 0.2, 0.3. 2 little boxes above baseline, 0.1, 0.2. That is going to be the basics of counting these intervals.
Alright, that concludes today's episode. If you liked what you heard, be sure to click the subscribe and like button down below. And as always, if you have any questions, comments, concerns, or if there's any particular topic you'd like me to create a video on, let me know in the comments down below. Alright, well, I look forward to seeing you on my next podcast.